Welcome to qnawire.
Hi, so here going to be given magnetite that we want to identify what is going to be the ratio of iron 2 plus and iron 3 plus that is going to be present on this sample. So in this case for magnetite, what needs to be satisfied is that we know that magnetite is iron 304, so we know that iron X times 2 plus with iron Y times 3 plus on the balance with oxygen, which is going to correspond overall to -8, needs to be equal to 0. So essentially the condition is given by x plus y is equal to 3, the number of atoms that we're going to have, and 2x plus 3y minus 8 is going to be equal to 0. So the conditions that satisfy this are going to be that y is equal to 2 and x is equal to 1. This is going to mean that the ratio of iron to plus with iron 3 plus that we're going to have is going to be a 1 to 2 ratio over here. Now we want to know what is going to be the type of spectroscopy that could be used to determine the relative abundances. And in this case, we're going to have mass power spectroscopy that is super sensitive to changes on the nuclei and on their balance state. So this is going to be the best technique in order to have a quantitative analysis. I have seen other papers in which they also employ, for example, X-ray absorption spectroscopy, or also some fluorescence techniques. But the best one is going to be mass power spectroscopy, even though it is super expensive. And finally, we want to state the number of protons, neutrons, and electrons in this case. So the table that you provided is actually correct. The species at hand are going to be iron 54 with atomic number 26. So the number of protons, neutrons, and electrons that we're going to have. In the first species, remember this is a 4, 54. The number of protons is going to be 26. The number of neutrons is going to be given by the difference of the mass with the number of protons, in this case 28. And since this iron atom is not going to be charged, the number of electrons is equal to the number of protons. On the other hand, we're going to have iron 3 plus 56, 26. So the number of protons is going to be stay the same. The number of neutrons is going to be 30 in this case. And now, since we're going to have 3 positive charges, that means that we're going to miss 3 electrons. So this is going to be our complete table. With that, it will be all. Thank you very much and have a good one.